All right, thank you so much. Hi everyone, I'm Jeevna Hegde, a machine learning and artificial intelligence specialist, customer engineer here at Google Cloud. I work on customers across India to solve for business challenges using AI and ML techniques. Really nice to have you all here. Today, we will be talking about how to solve for simplified automation using Vertex AI. Let me just present my screen. Yes. So today we'll be solving for simplified automation using Vertex AI and understand how you can leverage the same machine learning tools that power Google. This is our mission to enable every company to be an AI company. And with the experience and success of building ML tools and using it for our very own architecture and products, we are taking a giant step towards this mission by making these tools available to the world. But before jumping into the capabilities you can choose from, as an organization, it's important to understand your priorities as a company to transform to an AI domain. Based on your priorities, like how quickly you'd like to get started and the effort you'd like to put in, along with the expertise available in your organization, and the customization needed for the complexity of your use case, you can opt for which set of ML and AI options you would like to go for. Let me give you a quick run through of the different options that you can choose from the ML AI set of range from the Google Cloud. If you intend to get started very quickly with minimal effort and customization isn't really a priority, you can opt for the out of the box ML APIs like Translation API, Vision or Video Intelligence API, and so on. These are a set of ready to use APIs which are pre built and trained models. These are trained on Google's data. This requires you no code to get started and is simply a simple set of clicks away from starting off on AI. Then we have AutoML in Vertex AI. So let's say you need a little more customization and you have some time before you get started and you're ready to put in some effort and have a bit of expertise in doing so. You can use something called the Vertex AI in AutoML. This is for four types of data: videos, images, text data, and tabular data. If your use case fits into either of these, you can opt for AutoML. In fact, if you don't know which model to select from, although it's for one of these formats, it will automatically go through tons of models for you and choose and train for you. Just know that it cannot go for a combination of this. In such case, you'd have to go for Vertex AI in something called custom modeling. Which brings us to the third point. Third, if you have ML experts in your team putting in a lot of effort into building a model for specific needs and need a very customizable platform, we have Vertex AI with custom models. This way, you have custom building to training and deployment on a unified platform that we provide. This would fairly take you time to build to fit best with your complex use cases. And finally, if you have data scientists in your team and they may not necessarily be ML experts, we allow you to build your models on BigQuery ML with simple SQL like code. So you either stream in your data, or if you have your existing data, maybe even in petabytes in scale, stored in the BigQuery data warehouse, something like BigQuery ML or BQML can help you create descriptive and predictive ML models with SQL like code. This also takes some time and effort, but provides great customizability. Essentially, we have a range of options for you to choose from, but the idea is to understand your priorities and help you transform to an AI company. Just to sum it up for you very quickly, if you don't have your own training data and pre built models fit your needs best, ready to use ML APIs are the way to go. And let's say you have your own training data, but you don't plan on building the model, writing the code, so AutoML is the right choice for you. Well, if you do have your own training data and you plan on writing your code yourself, but in an SQL format, especially for data scientists, BigQuery ML is the right choice for you. And finally, if you have your own data and you want to build your own model in a non-SQL format, custom model tuning of Vertex AI is your perfect choice. Now understanding where Vertex AI fits in the broader ML AI aspect, let me help you understand a little more on what it really is. Vertex AI is an umbrella for building, training, deploying, and managing, along with scaling your machine learning workloads. It provides various options that we discussed earlier, which are your ML APIs, AutoML, custom model training, and your BigQuery ML in a single place. And because it's an integrated platform, your models can be reused. Pipelines can be built to automate things and create a workflow, and so on. This unified platform is built to create a seamless, secure experience and to provide flexibility for all users of different levels of ML expertise, whether you're new to the ML domain as a novice or an expert. Now let's try and understand AutoML in a little more detail. This is how a normal machine learning workflow looks like. So you load your data set, process your data to appropriate formats, do feature engineering on them, build your model, deploy it, and it ultimately makes you predictions. Of course, there's a bit of rerun here where you go back and forth to change your hyperparameters and see what creates your best model. But with AutoML, we are trying to skip a major chunk of the process with pre-built models. So you simply load your data and it is processed. Set your training budgets and AutoML takes care of the rest. By choosing a model, you entirely skip deciding your model architecture, tuning your parameters, and a lot of other work. Finally, giving you the predictions. This would be the fastest path from data to value. We'll even look at a quick demo for this very shortly. So the way this product works is that we provide a graphical, codeless interface guiding users through end-to-end machine learning lifecycle with significant automation as well as guardrails at each step. This will help you easily define your data scheme and target, analyze your input features in Feature Statistics dashboard, automatically train your model, including automated feature engineering, model selection, and hyperparameter tuning. All of this is automated. So you evaluate your model behavior before deploying it into production. And then deploying your model is just one click. Through this, we can help you ensure that what used to take you probably months can now take you weeks or even days. Next, we automatically search through Google's Model Zoo to find the best model fit for you. For simpler, smaller data sets, we can go for linear or logistic approaches. And for more advanced, deep ensemble methods can be used for the larger ones. Google's model portfolio include everything from feed-forward DNA, wide and deep neural networks, to gradient-boosted decision trees, and even combinations of these techniques, and so many, many more. The benefit of being at Google is you cherry pick. In fact, AutoML automatically cherry picks from the best research. This is a sample of a set of insights using NLP or natural language processing or document AI from AutoML for your unstructured data. We'll look at a demo as well to illustrate this shortly, but as you can see, this includes text classification, sentimental analysis, entity extraction, and many, many more. For custom modeling, honestly, going on and on with a set of slides isn't the best way. I will quickly do a run through in my demo of the features available to help you create a model from end to end with Vertex AI. But the idea is you essentially define your instance setup from uploading your dataset, building your own model, and running it with virtual machines with your choice of configurations. In fact, you can also include TPUs and accelerators as such to fasten your training process. And finally, deploy your model and test it. Deployment also includes various set of techniques. So you can deploy it in a sense of an endpoint, or you can have APIs connected so you can access them through the internet, and many more other types of deployments. All this from a single platform, and we'll look at the step-by-step procedure for this in our demo. You can do this with either the graphical user interface or through the command line interface. Now, finally coming to ML Ops. ML Ops, or machine learning operations, is like a system you build for automating the machine learning model's lifecycle. You standardize the building, training, deploying, managing, and operationalize your ML system to make it rapid and reliable, with humans intervening only when required. This is similar to the concept of CI/CD in your DevOps. To illustrate how these processes interact with each other at a high level, in the machine learning development phase, you use data sets from data and model management. The output here is the source code for the training pipeline. The CI/CD step for the pipeline is triggered by commits, merge, approvals, and so on. It builds, tests, and deploys the pipeline to its execution engine. The components are stored via data and model management. Based on retraining triggers such as maybe scheduling or new data or events or notifications, these triggers, the continuous training pipeline is executed that produces a model. The training pipeline uses data from the data and model management as well. Again, the training artifacts are maintained through the data and model management. Based on your model management workflow now, you can execute your model CI/CD to develop your ML model. This is deployed, serve your predictions, and you might be fetching values from the data and model management workflow again. And you also log the serving payloads to the database. These serving logs are used by the continuously monitoring to evaluate the model performance and identify data shifts and drifts. This would lead to updating information along with model in model registry or send notifications to data scientists to examine model via alerting system. So this might require some sort of human intervening, or even sometimes trigger a new retraining cycle instead of any sort of human intervention. Then you have the ML management, which is the ML model governance, etc., and data management. So whatever happens around data sets, creating new features, etc., is your data management. Beyond the development, training, prediction, serving, and monitoring that we talked about in our ML workflow, which is even otherwise in your custom modeling, your AutoML, etc., let me introduce you to something called the Explainable AI, which is a fairly new tool. Explainable AI, or XAI, is a set of tools and frameworks to help you understand and interpret predictions made by our machine learning models. With it, you can debug and improve model performance and help others understand your model's behavior better. You can also generate feature attributions for model predictions in your AutoML tables, BigQuery ML or BQML, and Vertex AI, and visually investigate model behavior using the What If tool. Let me briefly run you through the features of XAI and why this comes in handy. First, Explainable AI, or XAI, uses three robust methods for generating feature attribution methods. This includes sample Shapley, integrated gradients, and XRAI. Given that AI explainability is still a nascent field in developing our XAI product, we were very careful to vet and invest only those methods with the most robust and technical and theoretical foundations. All of the feature attribution methods that we offer are based on the concept what is called Shapley values. If you aren't familiar with it, Shapley values is a well-established cooperative game theory algorithm that assigns credit to players in a game being played for a particular outcome. In this context of machine learning, we treat each feature as a player in a game. And we assign a proportional credit to each of those features for the outcome of the prediction. For more detailed primary on Shapley values and a technical philosophy around explainability, I encourage you to check out our AI Explainable white paper, which is available in our product documentation. Moving on to the second feature. Explainable AI is highly flexible. First, XAI supports multiple different model types, including tabular classification and regression models, image classifiers, and text classifiers. Second, XAI is now supported both online predictions and batch prediction using use cases. Finally, XAI is compatible with ML models trained using an ML framework that is deployed as a custom container on the AI platform prediction or the Vertex AI prediction. XAI's third key noteworthy feature is that it is seamlessly integrates into three AI platform services today, so customers can get explanations right where they're building and deploying their models. As I explained earlier, XAI is currently built into AutoML tables, AI Platform's prediction service, and AI Platform notebooks or workbench. In addition to these existing integrations, more are in the pipeline, including BQML, continuous monitoring, and others. And finally, XAI is easy to use and scale. We offer an SDK that helps you users to get started immediately. The service is fully managed and serverless. Additionally, we've put a lot of effort into making explainability fast and resource efficient. One of the major blockers for customers is using explainability techniques in production today is the fact that it can get extremely expensive computationally, especially to apply at scale. Our service helps remove that barrier to adoption. Let me show you some snapshots of what it looks like to use Explainable AI as part of AutoML tables. What you're looking at here is for a vision API, let's say. So for image classification, and for this image of Husky, as I mentioned earlier, XAI provides users with explainability method called feature attributions. What this looks like depends on the type of data you're using. So it can vary for images to train an image classifier, tabular data to train a classification or regression model, or text data to train a text classifier, for example, for text-based sentiment analysis. But for each of these features, even it looks very different. And let's look at an image classifying um, for an image classifying algorithm here. So for images, feature attributions will show you which pixels or regions within an image most contributes to the model's classification. You can choose how you want your image to show these features as pixels, as boundaries, and you can choose the color coding. So you can have greens, pinks, etc. But for example, for this image of a husky, the model is focusing mostly on the husky's nose and facial features, which is likely what we would hope for in case we're looking for the model to classify dog breeds. Similarly, for tabular data, feature attributions tell you how much each feature column contributed to either a specific prediction or the model overall. And for text, feature attributions tell you how much each word or token in a sentence or utterance contributed to the sentiment score. So, for example, in a sentence, say, the cake tastes delicious. Feature attributions could show that the high sentimental score of up to, let's say, zero point 0.9 is largely attributed to the word delicious, which had a strongly positive influence on the text classification on the sentiments, whereas other words in the sentence significantly have lesser influence. The one other thing I wanted to cover before heading to the demo was to understand that if you have your own working models already, or if you want to just get started, why Vertex AI platform makes sense and why organizations are looking at it. Firstly, you're building and relying on best of Google. So using the products and solution built on the foundation of Google's pioneering AI research means that you can take advantage of the continuous enhancements that come along with it. And Vertex AI, a comprehensive ML platform, brings the best of Google's AI technologies in computer vision, conversation, language, and structured data, including a foundation of product excellence into one scalable unified experience. Next, to accelerate time to value. Accelerate your ability to deploy more models in production by materially increasing the rate of experimentation. In fact, we'll go through how most customers have increased their experimentation to up to 7 times with the help of making this time to value deployment accelerated. Sophisticated AI are made more accessible with flexible tools for streamlined and scalable collaboration across all levels of your technical expertise. So, like I said, your data scientists need not be ML engineers. And enhanced ML ops capabilities make practitioners' job easier with robust self service and workflow management. And finally, looking into trust and responsibility when you're handling data. Coming to responsible AI, all products must mandate to Google's robust AI principles, review processes so that you can trust the platform that it is built on with ethical governance. And as per Gartner Magic Quadrant 2021, Data Science and ML, Google has taken a clear thought leadership position in area of AI explainability and responsibility. Coming to security, you can minimize security risk with the leader among data security portfolio vendors. And Google Cloud powers organizations whose core businesses rely on data privacy and trust, such as Paul Alter Networks and the Mayo Clinic, and so many more. And quickly looking at sustainability, our AI products leverage our environmentally conscious infrastructure. On average, a Google data center uses 50% less energy compared to a typical data center. If you're interested in knowing more about any of these, we're happy to share some resources with you towards the end of this session. Finally, without any further ado, let's head on to the demo. Let me just quickly share my screen. Hold on. So, if you're new to the Google Cloud platform, let me just help you by giving you a quick run through. This is what you see when you log on to cloud.google.com, cloud.console.google.com. So, you can log in with your account here, and I've just done that. And when you're trying to provision any set of resources, you need something called a project. So, this is what you see in your dashboard here, your project information, which is your name, project number, ID, etc., and a couple of other resources which you've already provisioned, maybe. And you can also go ahead and, let's say, monitoring and edit reporting and a bunch of other things, just an overview essentially, which is your dashboard. You can go ahead and customize it. So let's say I want my billing information here. I can just toggle it over here and click on done. So you can see that billing turned up. So this is how you customize your dashboard. The next important feature is understanding the navigation menu here to the top left corner. So when you click on these three lines, you find all the products and solutions that you can provision, and you can navigate. This also is segregated to headers such as compute, serverless, databases, etc. Another feature is you can simply pin the resources that you probably need for frequent using. So once I pin it here, it comes up on top, and I can again go ahead and unpin it. And one other thing is you can also go to view all products. And because it's segregated into different subheadings, maybe I can go to artificial intelligence here. And yes, you can find your Vertex AI. Let me just quickly pin that. See, you can see that pop up here. And when I'm in any page, you can simply go to home to go back to your dashboard. The next thing is to understand your project's organizations. What I do is encourage you to look at organizations' IAMs and to understand what organizations are, projects, folders, etc. But essentially, you can go ahead and choose an organization here. So I can be in a no organization, and this is my first organization which I've created, and these are the set of all the projects available here. I can also go ahead and star or unstar these projects to see them appear here. And these are all the things if you want to go ahead and expand or um, shrink it. And these are the set of recent projects. And if you don't have any project to start, you can get started by clicking on new project here, giving it a project name. This cannot be changed later, so be mindful of what you're going to name it. And just click on create. Let me leave that for now. What you can also do is search for your products and resources here by typing in Vertex AI, let's say. So you can see that pop up here. So this is essentially a simple search bar. Next, we have something called Activate Cloud Shell, which is when you want to use a command line interface as opposed to a graphical user interface. So you can just open that here, and you can open it in an editor here, or go and look at the full screen here. So that's essentially your CUI. Just coming back to this. Let me close this for now. Yes, then we have your help tool here in case you want some resources, documentations, or want to reach the support. You can do that by clicking on the question mark here. Then we have a bell here, which is for all your notifications. So let's say you created a resource or created a new project or you deleted something. All of those notification activities come here. And then you have your three dots, which is for, let's say, project settings and a bunch of other utilities. And finally, you have to the top right corner if you want to switch accounts or if you want to sign out and so on. Now let's go ahead and navigate to the Vertex AI product. Like how you had a dashboard for your Google Cloud platform itself, you also have a dashboard for Vertex AI. Here you have, let's say, a bunch of data sets that you already have provisioned. If you have models that have been trained, and if you have some deployments such as batch prediction already deployed. So those appear here. Let me go ahead and show you what the datasets feature looks like. So remember how we talked about AutoML and custom modeling? Let's try and look at AutoML first. So if I go ahead and try to create a data set, let me name it maybe, let's call it G's demo something. G's demo TIE images. So let's call it that. Maybe I want it for image classification using single label or multi-label or object detection image segmentation. You can also see that there are three other options here. So you can have it for tabular data as in regression classification or for forecasting. Then you have it for your text data, so you can classify it using single label and multi-label, or you can have entity extraction or sentimental analysis. So you can choose which type of data set you want and just click on create. And finally, for video, you have video action recognition. So let's say it's for a baseball game, you want to recognize the exact strokes if you're doing them right. So something like that, or video classification or object tracking. So these are your different things. Let me just go to image. Let me select maybe object detection here and click on. In your advanced options, you get to choose whether you want Google's managed key or the customer managed encryption key. I would just use Google managed key for convenience, and I know it's highly secure, so I don't have any headaches there. And if I simply click on create here, it's going to take you like a second or so. Once the data set is created, it automatically takes you to as and when, like, let's say you've selected it. So this was my data set. So once I select this, I can go ahead and upload my files here. So I can do that, let's say from my computer, or import files from your computer, or select import files from cloud storage. If you're not familiar with cloud storage, it's the object storage option of Google Cloud. So this is essentially where your images lie, or any of your data lies. So let me select from my computer and I can select my files. So let's say I want Vision API. I'm just going to upload, let's say, these images. You can upload as many as you want, and 500 images per upload. So you can go up to uploading as many as possible. In fact, you can also stream them in directly to your Google Cloud storage. So you don't have the headache to sit and choose every single time. And instead, you can just choose your cloud storage path. Now that I have these files, I want to know where I actually am going to store them, which is your cloud storage bucket. And bucket is where your actual files lie in as objects. So I can either choose from a bucket that's already there, or I can go ahead and create one. And this needs to be a globally unique name. So maybe let's say, again, Jeeves demo TIE ML images. This I'm hoping is globally unique. Exactly. Now you can choose where you store your data, as in, do you want it to be multi-regional, dual region, or regional? So multi-region is for global, for it to be stored globally across different regions, and this can be especially used for disaster recovery. Then you have dual region, which is essentially for high availability, and then you have regional, which is in a single region in different zones. So let me go ahead and choose dual region here. No, I don't want any turbo replication, so I'm going to leave that. I'm choosing, you can choose from the different dual regions that you want, or new regions, you can go ahead and choose where you want to store it. In my dual region, I'm going to leave it at Iowa and South Carolina. Click on continue. Then you choose your default storage class. And these are essentially the steps you use every time you create a new bucket. Or if you've already created a bucket, you can simply put the path there, and these steps can simply be skipped. But essentially, your storage class is how often or frequently you're going to be accessing this data. So you can choose standard if it's frequently accessed, nearline if your data is accessed maybe once a month, cold line if your data is accessed once a quarter, which is once in 3 months, and archive for, let's say, like backups. Maybe you want to access it once a year or even lesser, maybe for auditing purposes. So that's where your archive comes in. Here I'm going to leave it at standard and click on continue. You can choose the control access that you want your objects to have. Uniform is the default control access, and fine grained is if you want object level permissions. What's suggested is uniform, which is why it is kept at default. You click on continue. You can choose how you want to protect your data. So if you have any retention policies, and this is especially used by, let's say, financial sectors where you need it to be retained for, let's say, up to 8 years. So you can have that. Or object versioning. So if you want different, every time you edit, if you want all the versions to be had. So this can be used for data recovery. I'm just going to leave it at none. Click on create. So now I have my Jeeves demo TIE ML images created. So I just select my bucket here, and that's it. All of these files are going to be uploaded to that. As you can see, these files are being uploaded. This is probably just going to take you a few seconds. All right, it's done. Let me just show you what an already existing data sets look like while this is being imported. So let's say I have a card demo as my data set. You can go ahead and browse all the items that have been here. So let's go back to something that's there. Maybe more customer images. So you can see there are 11 images here, which is of course not enough if you're training a model, but this is just an example. And I can go ahead, I can see the labeled set of images here and the unlabeled ones. Now, if I go and click on one of these images, and let's say I want to label them, I can use something called a bounding box. So I just have to drag here and give it a label. So maybe I would want to call this scratch and dent. Oh, space is not allowed. My bad. And then click on done. So now you have two different types of label. So you have just, hold on. Okay, I just need to save that, but essentially I've done this for dent, and similarly you can do it. Or you can simply use an annotation. Let's go back to this, which has been created now. I can simply annotate my set, either virtually like you saw here, or I can add a new different annotation set here. So let's see, analyze. This is the default annotation set that's been added. And similarly, you can go ahead and create a new one if needed, or upload something that's already available. That is essentially how your data set works. This is the region in which you're in. Now, moving on, we can skip features, labeling, tasks, workbench, and pipelines for now. We'll come back to workbench and pipelines very soon. But essentially, once you have your data set, you can go ahead and train your model. So I don't have any model right now. So if I wanted to create, I'm going to choose what I want my data set to be, what my annotation set is, and this is essentially where you choose AutoML, AutoML Edge, or custom training. AutoML is like we discussed for a pre-built model. AutoML Edge is in case you want to deploy it on edge devices like let's say your mobile phones or so. And custom training is something that we discussed saying it's for custom modeling. And it essentially has TensorFlow, scikit-learn, XGBoost, and another. We'll look into that. But first, let's just go and select AutoML here. I can give my AutoML model a name. So I'll just say AutoML. In my advanced options, I can choose the data split, whether I want the training validation test to be 80-10-10 or maybe 95-5 and so on. This is my split. I'm just going to leave it as it is. Then I choose my training options. So if I go for higher accuracy, it's definitely going to have higher accuracy, but might have a bit of a latency. Whereas if I go for a faster prediction, it might have a lower accuracy as compared to, but with lesser latency. So it's completely based on your priority. Let me just go ahead for higher accuracy here. And now is where I select the maximum node hours. So this is essentially your budget. You need a minimum of, you can train for as little as, let's say, 20 node hours based on what your data set is, or let's say 500. And I definitely suggest using enable early stopping here. So in case it's done earlier, it stops. So you're not paying for something you don't use. And just click on start training. This is essentially what this is. Now, instead, if I wanted to do all of this, but using custom modeling, I'm going to get a few more options here. Let's just look at that. So let's say my model name is so and so, custom, just to identify the difference. And in my advanced options, we have the same set of options here. Plus, I can use a service account. If you're not familiar, in your IAM, if you refer to that, you'll understand what a service account is. It's almost like giving an account all the access details. And then you can choose your network, whether you want it to be pure VPC or so. I'm just going to leave all of that as it is. In fact, another important feature could be enabling training debugging. So this will help you debug while you're training itself. Again, you have your high accuracy or faster predictions. I'm just going to leave it. Okay, let me select faster predictions. Now you have something called a training container. This could be using a pre-built container, as in if you want your model frameworks to be in a PyTorch, scikit-learn, TensorFlow, or XGBoost. And you can select your model version here. Let's say I want the latest one, 2.7 for TensorFlow. And then you can go ahead and add your pre-built container settings. But just to look at the other one, you can also build your own Docker container. So all you have to do is browse where you've stored it, where you've stored your container image. This would be stored in something called the container registry. So I just browse the URL and then the dataset export directory and output directory. These two options you also have, of course, in your pre-built container. But let's just say I have used Python. Let's say I want to browse a path. I already have a code here. So if you go ahead and see, there's some thing here. It's just for a demo, so it's not really what we're using. But if I go ahead and select this, just for the purpose of this demo, I can go ahead and add different packages as well. And let's say for my Python module, I have something which maybe I stored in the GitHub repository. So I can just browse that here, or I can type that in here. Oh, sorry, this. Yeah, this is my Python module, and this is for your export directory and dataset export directory and output directory. So I can browse where I want it to be. Maybe I want it to be in this. And again, similarly, I want it to be in the same bucket. So that's all I'm doing here. I can also add optional additional arguments. Then if you want hyperparameter tuning, this is where you go ahead. Maybe you want to add the number of perceptrons or the number of layers. So let's say I just click on enable hyperparameter tuning. I can maybe name it deep layers. So how many deep layers I want? I definitely want it to be an integer. I can go ahead and choose a min and max value. So minimum, I want 3 players, and maximum, let's say I want 7. And I can choose whether I want it to be no scaling, linear, linearly scalable, log scalable, or reverse log, and just click on done. So you can just add your hyperparameters here, and you can choose the metric on how you want to optimize and what your goal is. So do you want it to have your maximum or minimum based on what your parameter is, hyperparameter is? And I can choose my algorithm here. Default is it would go ahead with the best suited, or you can choose grid search or random search. Let me just disable it for now. Click on continue. And this is essentially where you choose what virtual machines you would want for your training. So let's say I'd say high CPU. So N1 high CPU, and you can like I already mentioned, add some accelerators. So your TPUs, something smaller, and you can choose the accelerator count. And you can add your disk type, so SSD for faster disk and standard for, let's say, regular, but for ML, usually SSD is preferred, and choose your disk size here. Click on continue. Now you have a prediction container, so you can go for no prediction container. So you can always import your model artifact later to serve a prediction request. So this is a step that you can also do later, which is why it's optional here. Or you can choose a pre-built container or custom container like what we saw earlier. But this is for the case of prediction containers. Let me just go with no and click on start training. Unable to start due to an error. Okay, there's this essentially some error, but basically this is how you create your custom models. So you can go ahead and in your training containers is essentially where you bring in your own containers or use a pre-built one. Yes, this is for the purpose of this demo, so let's just leave it as is. Now, instead, if I go ahead and share this tab, I've gone to a Vertex AI mode here already. You can see I have a bunch of different data sets and I have some recent models as well, which have been trained, and notebook instances. We'll come to it in just a bit. So now if I go to training, you can see all the models that have been trained. So let's say I am going to look at maybe a pneumonia explainable AI. So this you can see which type of model type, what the model type is here. So this is for tabular forecasting. There's text classification, image object detection, and so on. So if I say I go to the pneumonia explainable AI model, yeah, it's just going to take a second. But yes, for the trained model, it shows you all the different labels that you have. So before this, let me just go to the data set and show you what the pneumonia data set looks like. Hospital intake, is this the one? Sorry, this isn't the one. Okay, let's just look at it for a different one. Maybe for AutoML movies. For text data, what the data is, I can see that I have about 42,000 set of data that I have trained my model on. So you can go ahead and see how many are available over here. And you can see how many are unlabeled versus how many have been used for training, how many have been used for validation, and how many for tests. So the train validation test split and the different labels that are available here. So for your comedy, crime, and a bunch of different labels. Now, when we go back to our pneumonia data set, model, you can see that the two labels that I have here are maybe the ones that had pneumonia and maybe the ones that did not. So maybe the scans of pneumonia versus normal. You can also see the precision recall curve here with different thresholds. So let's see. I increase the threshold to 0.67. You can see that. And then you have the confusion matrix. So how many times the model predicted it right? So when it was a normal scan and it was detected as a normal scan, and when it was pneumonia scan and it was detected as pneumonia. So that is essentially a confusion matrix. Now, if I go ahead to deploy and test, I have a bunch of different endpoints here. So essentially for every model that you do create, you have something called endpoints that you can see here, which needs to be deployed. And once you deploy it, you can simply test your module. So let's say I add my image. So if I go to desktop, this is a normal scan, which I'm using for testing. And let's see if it predicted it as normal. Yes. So you can see that it was, the majority was predicted as normals. And similarly, if I go to the pneumonia one, which I've used for my test image, this is for a pneumonia scan. It predicted it as pneumonia. So this model is working fairly right. Of course, you can go ahead and have batch predictions as well. That can be done. And like I said, you can also have internet with internet streaming in for your testing of the model. So that is your model. Let's look at another model, maybe this time the movie genre that we looked at. In my training model. So, okay, view training data set, not interested. Yes, this is, oh, this is talked, hold on. This is the one. Let me go ahead and look at it from endpoints, in fact, not instead of models. So let's say these are all the endpoints I have deployed. So you can have multiple endpoints for the same model. And you can see in your models how many endpoints are being deployed. So here, if you move to the right, you can see that for this model, 0 endpoints were deployed. And for this, there were 3. For airline tweets, there was 1, and so on. So now for which model were we looking at? Movies. If I want to go ahead and, oh, I can look at the, again, sorry, I'll just go back. Yeah, these are all the labels that we saw. Of course, this is fairly higher than just pneumonia or normal. This is the precision recall curve again. And then now if I go to deploy and test, let's say I want to test my model now. So I can just type in any random movie stories. So let's say the alien crashed on Earth and the robo saves the world. So I would expect this to maybe be a sci-fi sort of thing, maybe an action as well. That's right. Maybe there'd be some comedy here, but essentially you can see the majority it's identifying it as science fiction. And similarly, let's say I put in a different thing, saying Jane dies in an accident, but it doesn't seem to be a coincidence. So who is the killer? So maybe, yes, of course, it might be drama, it can be thriller, horror, mystery. So you can see how much of each of these it's classified it as. So that's your text classification model. And similarly, you can have multiple different models, and this is your AutoML. And I think that's it. Maybe one other thing I'd like to cover quickly is if you go to one of the AIs, the ML APIs, which I already talked about, which are ready to use, you can also have your own try document AI. So if I just put in an invoice here, this is publicly available. So you can just do that. If I just put in an invoice, you can directly test it over here. It's just going to take a second. Yeah, as you can see, it classified it. And this is your document AI. So you have your ML APIs, you have your AutoML, and you have your custom modeling and BQML. Right, that brings us almost to the end of the session. The only one other thing I'd want to cover very, very quickly is now that you have an idea of exactly where it is, what Vertex AI is, and how you can get started, etc. Maybe your first set of actionable steps would simply be, hold on. would simply be understanding your particular business problem. So you can go ahead and maybe look at use cases on a customer page as to what customers of in the same domain are looking at. So sales demand forecasting, detecting defect in images, etc. And once you'll know exactly how and which tool to use on the Google Cloud platform. And that brings us to the end of this session. I really hope you enjoyed the session. And if you have any questions, feel free to reach out to me and I'd be glad to help you out. Thank you very much.